because the Unit 4 retake deadline is Thursday, for those of you that are interested in retaking, hopefully this Unit 4 review was helpful. And it kind of puts all of the conversations of triangles together. We've got one more piece of the puzzle that we're going to start this week and continue on when we get back from winter break. Classifying triangles should not have been a problem, or sometimes, always, never should not have been a problem. And these diagrams in 13 and 14 you've seen before. They were on your quiz from Unit 4. And I believe on your review packet. So none of that should have been new. 15, 16, and 17 was all about triangle sum theorem. So taking our expressions, adding them up to 180, solving for x, putting that in, and then classifying the triangles. So it was tedious work, but not difficult work. Down here I have 3 different versions of an isosceles triangle. So because I know the sides are the same, I know the base angles are the same. So here I can set these two angles equal to each other, solve for x. When I plug my 22 in for x, I get each of these angles as 55. When I add them together, that's where that 110 comes from. That's 2 times that 22 for x plus 11, and then I have 2 of them. That's where that 110 comes from. Number 2, I set up a system of equations. It was a pretty, not complicated, but it was, I went ahead and solved the system. And somebody last class just said, well, since that's right, and these are isosceles, can't you just set each of these equal to 45? And I was like, yeah, absolutely. Did anybody else see that? Yeah. So I got so heavy into the math, I missed the easy stuff. So, but it's okay. I got the same answer, so we're all good. Number 3 is isosceles. Setting the angles equal to each other, adding up to 180. Not a problem. All right, on the back of this page, now these 3 triangles were from the Unit 4 review packet. So we went through them. So I brought those answers back, but if you want to see those, the work specifically, check back in on your Unit 4 review. My philosophy for this is I'm always going to find, first of all, the longest side, circle it, and then I'm going to add the other 2 together and make sure it makes a triangle, because the sum of the 2 smaller sides has to be bigger than that 3rd side. For this one, the range of x values I find is 5 to 17. But remember, we're talking about perimeter. So that means that if I add 6 and 11 and 5, I get 22. If I add 6 and 11 and 17, I get 34. So the range of the perimeter is just going to be 17 more than the range of my values for x. So that's just one extra application step. And reviewing those inequalities with what's bigger, what's smaller, what's shorter, what's longer, and whatnot. I love number 11. LM is like that go-between, between the small triangle and the big triangle. He's like the middle child of the family. He's the longest of the little triangle, but he's the smallest of the big triangle. Go ahead, Owen.
How do you get 115 degrees?
I got that. How did I do that? Let's revisit, because it doesn't seem right, does it, Owen? All right. So I got this, 95 and 30. I don't think that's 115 degrees.
It should be, the last 2 should be MN.
So this is backwards then. So 95 and 30 is 125. So that makes this is 55. So LM is my smallest. And then N, and then MN. All right, you can go put Smarty up. Thank you. That's better. It makes me nervous. Last class didn't get that. So they're not paying attention. All right. So for this page, if I know that measure of angle L is my largest, that means that the side opposite is my longest. So I don't have to worry about using two inequalities to find x. I just know that the sum of these two sides has to be bigger than this side. So 6x minus 20 plus 4x has to be bigger than 2x plus 10. So x has to be bigger than 15/4. Here's some hinge theorem. If I have two sets of congruent sides, when I'm talking about the angle and the side opposite it, the larger side is opposite the larger angle. The Pythagorean theorem and its converse. Any questions there? And then, of course, using that converse to determine what kind of triangle I'm. Again, I circle my biggest side, and then I do a test, because if 15 and 17 is not bigger than 34, I save myself a lot of work by saying that's not a triangle. Yeah.
What, can you explain Pythagorean triple?
So if it's a Pythagorean triple, that means that all of my values are whole values. So no fractions, no radicals.
That's it? It's just,
That's it.
it's
Because-
the Pythagorean theorem and they're all whole.
Yeah. So think back to that video we watched where Pythagoras was obsessed with whole values, and he really didn't understand back in those early days what fractions or irrational numbers were. So he was obsessed with those triples that all worked out evenly. Use the distance formula to determine if the triangle with the vertices is acute right or obtuse. So we can put those coordinates through the distance formula. It's an acute isosceles. So that's a little bit, that's your Unit 4 review. After this, we jump into Unit 5, talking about congruence. It's super important that you understand notation. If we're talking about angles, you have to make sure you're telling me it's an angle. If we're talking about the measure of the angle, you better have degrees on it. If it's the distance, you better have units. Segments, that line on top tells us it's a segment. The degrees tells us that's an angle measurement, and this triangle tells us that shape is a triangle. Identify any figures that can be proven congruent. So we're given enough information to prove those triangles are congruent, and we can say, you know, we have enough information that anything there, side, side, side is good. Side angle, side angle, side angle. Hypotenuse, leg, works for them all. Careful of number 9. Those are two isosceles triangles that are the same shape, but not the same size. And then, of course, I have number 10's right triangles. 11 and 12 are about using corresponding parts. No problem there. Please take the time to check all of these angles. And the congruent triangles. And your justifications. Was there a question? Which one did you want to talk about?
Number 9.
So number 9, it has to be angle, angle, side because I only have one side. So even though this is a right angle, because I have this angle and this corresponding side, it can't be angle, side, angle unless I use the third angle theorem to get K and J and G. And it's not hypotenuse leg because I don't have a leg. Does that make sense? Be really careful that if you determine things are parallel, that you don't mix those symbols up with congruence. Parallel and congruent are 2 different conversations. Go ahead.
Does it matter, like for number 9, if I put side angle in it, does that make a difference?
No, that's fine. Anything else with the triangles? All right, here's our last set of congruent triangles. If it's easier for you, if you find yourself getting twisted up in angles that are flipped or turned or backwards in any way, take the time to draw them. Take the time to put them in the right orientation, and then it's easier to match up parts. So once I flip this guy around, I can see that D and T, but more importantly that A and S correspond and K corresponds. Once I take this triangle and I rotate it up, it's easier for me to see what is or is not congruent. So if you're having a hard time, sketch the triangles in the same orientation and that'll make it easier for you. Go ahead.
Why is 9 not?
Because nobody said that this was a right angle. So I have one angle and 2 sides, and that's angle, side, side. Yeah.
Never mind. I was going to say, is it asking K and Kn if they're equal to each other?
Yeah. And that's the difference between the 1 and the 2, right? When I have 1 and we match them up. And the angle bands do that too. If I have 2 sets of angles, a lot of times they'll draw 2 angles. All right, now let's talk about the proofs. Well, one more. So for 7 and 8, or 5, 6, and 7, and this is a really important part. So triangle congruence sometimes isn't the end game. It just unlocks other information that we need. So if I'm able to prove side, angle, side, triangle congruence, those 3 pieces of information that give me the congruent triangles, they unlock everything else. So there's like the magic code. Think of like if you ever do any one of those escape rooms or whatever. Once I have the triangle congruence, then it unlocks all of the other information that I need. I can get those 2 angles, D and B, congruent. I can get the angles down by where Y and A are congruent, and I can get those missing sides congruent. Go ahead.
Can there be different answers?
So, no, because unless you named your things different. So I already have this 1, 2, 3 pieces of information. So because of side, angle, side, I now get angle D and B. Because of side, angle, side, and CPCTC, I get BAY and DYA. Now, if you named these 2 angles opposite of me, if you named them YAB, and if you named it AYD, then that would be okay. But this is what I get because of what I'm given. This is what I get because of CPCTC. Corresponding parts are congruent, triangles are congruent. With number 7, I had to use segment addition postulate because GH is congruent to itself. So then if this and this were congruent and I added the same thing to them, then their new NH and GH are now going to be congruent. And then once I get, I really didn't need it because I had this, is this given to us or is that my marking?
It's your marker.
Yeah, so it's angle, side that I needed. So the proof, I really like these two proofs because one, we have to get the triangles congruent and then we use CPCTC to get what we've been asked. We've been asked, can you prove that S and W are congruent? Notice I pulled the triangles out so I can see my corresponding parts easier. So what was hard about this one is the diagram gives us that those things are congruent. If we wanted to be really fussy, we have to go from congruence to equal measures because I needed to do a lot of segment addition postulate and substitution. Because I had this congruent to this and this congruent to that, so I had to add them. This plus this is going to equal that plus that. And then that's some of the substitution I did here. Once I got those triangle sides, these pink ones, S and R and W, then through side angle side, I had my triangles congruent. Once I have my triangles congruent, then getting S and W is easy because corresponding parts are congruent, triangles are congruent. That would have been a lot easier if I'd been given the distances were equal. Then I wouldn't have had to do this stuff. But I still would have had to do that. What I like about this proof is we're given two triangles are congruent. ACB, this one here, is congruent to this guy here. So because we're given the fact that those triangles are congruent, like how weird is that? At the start of the proof, step one, these are congruent. You're like, oh, check it out, they're congruent. Now, right in step 2 and 3, I'm using CPCTC because I'm getting the information from those to use in proving these other shaded triangles are congruent. I got these corresponding angles are congruent. I got these corresponding sides are congruent from CPCTC. Of course, I have my vertical angles, and then I have angle, side. That's how I prove those other triangles are congruent. Go ahead.
Can you explain how CPCTC is the justification method here?
Yeah, so it's easier if I draw these triangles. So here's A, B, C. And here is B, D, C. So they told me that triangle ACB was congruent to triangle DBC. So everything about these triangles is the same. This side is congruent to this side. This angle is congruent to this angle. This side, this angle, this angle, this side, this angle. So that's what I'm given. So what I need for my shaded triangles, these are the triangles I'm trying to prove congruent. I don't need all that stuff, but it's almost like you're out shopping. Ooh, I need A and D. So I'm going to give myself those angles are congruent. BAC and CDB. That's nice. I know this side is congruent from the reflexive property. Well, but that has nothing to do with what I'm doing. It's this side that I want. AB and DC. That's my side I get from CPCTC. And then here are my vertical angles. Once I have that information, I've got angle, side for these shaded triangles. All right, so here's a conversation for all you proof skippers. You gotta stop. You gotta stop skipping the proofs because you know they're on your tests. The whole unit is about triangles and proofs, proving them congruent, using corresponding congruent parts. It's all about proofs. So the problem is, if you're saying no thank you every single time I give you a chance to practice, That's like if you're playing soccer and your team never practices corner kicks. Or never practices penalty shots. Like, you gotta be ready. And every time you say no thank you, and you don't just put your head in it, you don't force yourself to put pencil to paper, you showing up with blank proofs is like a soccer team walking into a match never having practiced penalty kicks or corner kicks. You would never do that. So for all my no thank you words, you guys start saying yes please. Because the only way to learn math is to do math. Any questions before we move on?